Did you know that over the past decades, the sea level has risen? All these news are related to climate change. But what is climate change?
Good day, everyone. I am Ma'am Kat, and today we're going to talk about something that affects every single one of us climate change. But before we go there, we first need to understand two important words that people often confuse climate and the weather. So, what's the difference? Well, weather is what's happening outside right now or in the next few days. It's the rain, the sunshine, or the wind we feel. It changes quickly. One day it's hot, the next day it's raining. Climate, on the other hand, is the long term pattern of weather in a place. It's what we expect over years. For example, if you live in the Philippines, you know our climate is tropical. It's generally warm all year. But when it rains heavily for a few days, that's just weather. Or imagine you're planning an outdoor event in Thailand. You'd pick a summer month because you know the climate there is warm during that season. But you can't be sure it won't rain on that specific day. That's the weather. So remember this simple line. Climate is what we expect, and weather is what we get. Now, some people still get confused when they hear about climate change. They might say, "Oh, it's really cold this week. Where's the global warming?" But one cold week doesn't mean the planet isn't heating up. Climate change isn't about what happens in a few days. It's about how the Earth's average temperature changes over long periods of time, like decades or centuries. So, what is global climate change? It's when the Earth's long term climate patterns like temperature, rainfall, and winds start to change significantly. Scientists study this in three ways: the evidence of climate change in the past and present, the causes or what drives it, and the effects that we see today. Let's focus on the first one, the evidence. Scientists obviously can't go back in time with a thermometer, right? So, how do they know what the Earth's climate was like thousands of years ago? They use clues from nature, also called climate proxies. These are natural record keepers that store information about the past. One of the best examples is Antarctic ice cores. These are long cylinders of ice drilled deep from the polar ice sheets. Think of them as Earth's frozen time capsules. Each layer of ice represents a year, like the rings inside a tree. And trapped inside those layers are tiny bubbles of air, actual samples of atmosphere from thousands of years ago. By studying those air bubbles, scientists can find out how much carbon dioxide and other gases were in the air back then. It's like reading Earth's diary, page by page, year by year. And what did they discover? Over the past 400,000 years, the Earth temperature has gone up and down in natural cycles. During colder ice ages, carbon dioxide levels were low. During warmer periods, carbon dioxide was higher. This shows a clear connection. When carbon dioxide increases, the temperature rises too. But here's the shocking part. What's happening today is different. Before the late 1800s, temperature changes took thousands of years. Now, in just a few decades, carbon dioxide levels have skyrocketed. Why? Because of human activities. We burn coal to make electricity, we burn oil to make our cars and planes move, we use chemicals to make things, we cut down lots of trees, we burn gas to cook food, and we dump lots of trash on landfills. Scientists have also looked at graphs that show this pattern clearly. One graph shows how temperature has changed, and the other shows carbon dioxide levels. Both move almost exactly the same way. When carbon dioxide goes up, so does temperature. And before humans started using coal and oil, carbon dioxide levels were between 180 and 300 parts per million. But they've gone far beyond that, higher than at any time in the last 400,000 years. That's why scientists are certain This isn't just a natural cycle, it's human driven and it's happening fast. Besides ice cores, scientists also use three rings, ocean sediments, and fossil records to study past climates. All these sources tell the same story. The Earth's climate is changing rapidly, and people are the main reason behind it. In short, the evidence for climate change is strong and undeniable.
So, what should we do? We need to change the way we live so we can stop releasing so much greenhouse gases. That way, the Earth's blanket will go back to normal. We also need to be ready for what climate change will bring. So, let's all come together as one global community to make a difference.